I've just set this moving, so it's undergoing what is known as simple harmonic motion. So it's been pulled away from its equilibrium position, its rest position. So it's undergoing displacement, and of course it's moving so that it's got a velocity, and it's changing direction as it goes up and down, which means that it's accelerating. So what we're going to do is to explore the relationship between its displacement, its velocity and acceleration. To do that, we've got a motion sensor down there, and that motion sensor is connected to a data logger, and that data logger is connected to Pasco. So what we can do then is have a look at the displacement, velocity and acceleration of an object undergoing simple harmonic motion. So here I am now at the computer, and I'll click on Pasco and click on this icon up here in the top left. Notice here that it's all connected, everything looks okay, so I'll close that. I'll double click here to get one graph, get another graph and a third graph, and I'll position these graphs so that they're sitting under each other. And here now is the position one, here is the velocity one, and here is the acceleration graph. So these are the graphs that we get from our data logger. Now if we have a look at the first position where the mass has gone up to its highest point, you can see here that we've got maximum displacement from the equilibrium position. Now, if I draw a tangent to that, in other words, I get the gradient, you can see down here that the gradient is zero. In other words, the velocity is zero. Now, as it moves down and it gets back to its equilibrium position, there's the displacement. If we have a look at the mass when it's in its equilibrium position, you can see here that the gradient of the displacement is, first of all, negative, and secondly, it is at a maximum. It's the maximum backward slope, and that gives us the velocity position here, namely it is negative, okay, -1, and a maximum. Again, as the mass moves down to its lowest point, we note that the velocity is zero. It's the turning point. It's the minimum velocity, zero. And the next position here that we note is when the mass is back in its equilibrium position, and that's around here. And you'll notice there that the velocity is at a maximum, and it's in the upward direction. It's in the upward direction. It's moving in a positive direction. And so it continues. So our next one here, we have the mass in its most positive position upwards, and the gradient of the displacement graph is zero, and there it is. So let's have a look at the acceleration now. Of course, we get acceleration by having a look at the gradient of the velocity graph. And if we have a look here, the gradient is negative and a maximum. So down here, that's where we see it at -1, negative and maximum. As the mass moves down and it's in the center here, and we look at the velocity here and we look at the gradient, we notice that the gradient is 0. And so here the acceleration is 0. Again, as the mass falls down to its lowest position, then what we find is that the velocity is 0, which is what we would expect. That's where it turns around. However, the acceleration is at a maximum. And notice that the acceleration is positive. In other words, it is up. So the displacement there is down. There it is there. The displacement is down. The acceleration is up. It is in the opposite direction to the displacement. Moving along, when we have a look at the mass when it is in its equilibrium position again, it's passing through that middle position, its rest position, the velocity is at a maximum. Okay, that's the gradient here, as we said. But then when we have a look at the gradient of the velocity, we notice that it's 0. And that's exactly where the acceleration graph rests here. And it continues moving upwards, and we're back into its original position that we started there. And of course, we've got maximum displacement upwards, maximum acceleration downwards. So it is accelerating downwards at the same time as the displacement is upwards. So always opposite. Now, again, as far as the acceleration goes, the acceleration, as I said, is 0 when it is right in the middle. So the acceleration downwards starts as this moves up. As it moves up, the acceleration down increases till it gets to there. And the acceleration down is a maximum. And then the acceleration starts to decrease until it gets down to here. So our summary now is this. When the mass is down, we can see here that we have maximum negative displacement downwards. We have maximum positive acceleration, and the velocity is 0. As it passes through the rest position, we have 0 displacement, 0 acceleration, but maximum positive velocity, maximum velocity up. Once it gets to the top, we have maximum positive displacement upwards. However, maximum negative acceleration downwards. And that acceleration downwards increases the further we get towards the top. And coming back down again, we have at its equilibrium position 0 displacement, 0 acceleration, but maximum negative velocity, maximum speed down. And once we get back down here again, it's the same as what we've got across here. Maximum negative displacement, maximum positive acceleration, and 0 velocity. So those are the relationships of our 3 things that we're interested in: the displacement, the velocity, and the acceleration of something that's undergoing simple harmonic motion.